This is joint work with my collaborator Anna Kornfeld Simpson, who's also a graduate student in our lab. We're co-first authors. I just happen to be giving the talk. And with my advisors, Yoshi Kohno and Franziska Roesner. So to start this talk, I want to convince you of two things very briefly. One is that web tracking, third-party web tracking, is an important thing to study. And the second is that we should be studying it over time, longitudinally. So first, I need to tell you what I mean by third-party web tracking in the context of this talk. Simply, it's a fairly simple concept. What I mean is the ability for some entity on the web to build a browsing profile about a user. And that profile simply consists of a list of places on the web that a person has been. For example, this list of sites here. So what's troubling about such a profile? Well, if we use machine learning, we can learn a lot of subtle things from even a fairly innocuous list of sites. But people also use the web for explicitly sensitive things. They explore religion and health. They look at mental and physical health, sexuality, politics. And leaking this type of information can carry serious economic and social and even physical risks, depending on your context. Additionally, there's been a lot of psychological work on the effects of being watched. After the Snowden revelations, it was shown that views and edits of privacy-related Wikipedia articles declined because people felt like they were being watched. And it turns out that if you put a pair of eyes, sort of like those ones on the top of the page there, next to a communal coffee pot, people will actually donate more money towards the communal coffee. And these are really subtle, pervasive effects. And so being watched by web trackers could have similar effects, I wonder. And so I think studying them and understanding how we're being watched is important to understanding this sort of thing. Second, I'd like to make the claim that we should be studying web tracking over time. I think we should probably be studying a lot of things over time. We have been studying web tracking. There have been papers for about 7 years now. The oldest one was from 2009 and used data ranging back to 2005. But we don't really have a good sense of what was going on with web tracking before then. Moreover, I think we want to know about trends here. We want to know how the development of these techniques relate to trends in web tracking. And these studies are all done in various different methodologies. And so they're hard to compare over time. And so I think it would be cool if we had a way to look at web tracking over time. And fortunately, we do. In this paper, we've come up with an idea. And that idea is to use time travel. And you're all looking at me kind of funny, kind of with expressions like this right now. But I'm serious. We actually have a limited form of internet-based time travel. So I'll take you on a time travel journey right now, back to 1996. Here's usenix.org in 1996. And this is a snapshot of usenix.org, which was archived by the Wayback Machine. The Wayback Machine is operated by archive.org, which is called the Internet Archive. And they've been archiving the web since 1996. And you can see up at the top of the page here that there's this histogram of snapshots of this page, reaching back a whole lot of snapshots. The Wayback Machine is actually quite extensive. It has 11 petabytes of websites archived. An individual website is quite small, so that's a lot of snapshots of a lot of web pages. And importantly, these website snapshots contain JavaScript, they contain HTTP headers, they contain all kinds of embedded resources. And you can load them up they're served by the Wayback Machine's web servers, and you can load them up in a website. Your browser can execute them. So you get all kinds of dynamic client-side behavior, like the JavaScript executing and whatnot. And so we saw this and we thought, hey, maybe we can perform measurements in the past. Maybe we can say, well, we didn't think to measure it back then, but now we can measure something like web tracking. And we think we can perform what I'm going to call retrospective web measurements. And in this talk, I'll demonstrate that we can by telling you about a 20-year longitudinal study of web tracking that we did using archival web data. I will give you the talk in 1 minute as sort of an abstract. If you want to pay attention now and not for the rest, you might get more out of it than any other way. So we started with this insight that web archives exist, that they might be able to enable retrospective measurements of the web, and we decided to do an archaeological study of web tracking to demonstrate this. The world is not perfect, neither are web archives. We found that they're sometimes incomplete and sometimes inconsistent, and this leads to a lot of challenges. We spent a lot of time uncovering and quantifying and mitigating these challenges, which led to the implementation of our tool, TrackingExcavator, which performs these retrospective measurements. We validated those measurements by looking and comparing them to trends in the live web over the last 5 years. And then we were able to do a bunch of measurements and draw a picture of web tracking and how it's changed and how it's evolved over the last 20 years. So in the rest of the talk, I'll get into the details of all of this. And to start, I'll tell you how web tracking works in the model that we're thinking about. So first, we need a definition. A first party is just a website that you go to intentionally. You type in a URL, you type in cnn.com, and there you are. CNN is your first party. If there are CDNs or advertisers or other third parties that are embedded inside of CNN, then those domains are third parties. And we're worried about those third parties following you around the web and learning about you. If you recall from what I said earlier, our definition of third-party web tracking is the ability for one of these third parties to link together different places you've been on the web and form this browsing profile of you. So technically, how does this work? Say that I'm sitting down and I want to read some news. So of course, I go to theonion.com. And my browser starts the process of loading the Onion, loads the logo for the Onion. And then it sees that the Onion contains an advertisement. And it makes a request to tracker.com, which is serving the advertisement. Tracker.com sees this request, and it does a few things. It says, I don't know you, so I'm going to assign you a new unique identifier. Call it 789. I'll write that down in my browsing profile database over here. And I'll write down that I've seen you at the Onion. And then it picks an advertisement, say this picture of shoes, and it sends it down to me and asks my browser, hey, can you remember that for tracker.com, you are ID number 789. My browser does that. And I browse the Onion for a while, and I start to wonder whether maybe this is not, in fact, a real news site, despite what the tagline says. So maybe I go looking for some real news. And I've heard of CNN.com, so I'll try them out. And I go to CNN, and I load some resources from CNN. And then my browser also sees that there's an advertisement on CNN, and it just happens to also be served by tracker.com. And so my browser makes a request for this advertisement, and it sends along with it this cookie. It says, oh, and by the way, you know me. I'm number 789. And the tracker says, oh, great. OK, so I know you. So I'll add CNN.com to this browsing profile, and I'll pick an advertisement for you. You seem to like onions, so I'll send you an advertisement for onions. And so after this, you can see that over on the right here, tracker.com has started to build up a browsing profile. Right now, it consists of 2 sites. But as I continue to browse the web and see tracker.com in more places, it will gain more information about me. So the rest of this talk is structured around the contributions of the paper. First, I'll talk about the tool that we built, TrackingExcavator, and the challenges that it responds to in doing retrospective measurements. So let me tell you about that tool that we built. I'm going to give you a high-level overview right now. You don't need to read the detailed text on here. It'll come back later when I talk about the challenges and how we respond to them. For now, I'll give you a high-level picture. First, what we do is that we generate inputs. So for this study, what we used was the top 500 most popular sites for each year. So there was a different set of 500 sites for each year. And the first stage of the tool takes in that list of sites, and it takes in a timestamp in the past, and it combines them, and it sends them off to the Wayback Machine and says, hey, which snapshots of these pages do you have at this timestamp? And it picks the closest one that it likes the best. And it takes those snapshot URLs, and it feeds them into the automatic browsing part of the tool. The automatic browsing happens inside of a Chrome extension. It automatically browses those snapshots of the past web. It collects events. So it collects all of the HTTP requests made and all the responses to them. And it collects other tracking-related events that happen, such as API calls in JavaScript that might set cookies, for example. And we store those events into a database so that we can do that, so we can do analysis offline. And then in the analysis portion, we pull those events out of the database. We basically replay them. That's what our analysis tool does. And we replay them looking for tracking behaviors. And so this whole structure of input generation and munging, browsing, data analysis is all very similar to any web browsing, any web crawling analysis, any measurement. So what makes this hard, given that this has been, this basic structure has been followed before? There are a few different things. And one thing I want to point out here is that I think that identifying and evaluating these challenges is in and of itself a contribution of this paper, because both our understanding of these challenges and the tool that we built will be really useful for doing future measurements of this type of all kinds of other properties of the web. OK, so cookies don't work in the archive. Why? It's because the archive preserves headers, right? So here's if the original site set a set cookie like this, the archive will give us back this archive version of the header, and our browser doesn't know what to do with it. We record it in the database, and so we have to handle it in our analysis scripts. So in the analysis scripts over here, down here we see where it says cookie simulation. What we basically do is there's a whole section of our analysis code which simulates a browser's behavior with cookies. This is a bit challenging. We're doing it in Python, and Python's cookie libraries don't precisely mimic the way that browsers actually handle cookies. So there are some challenges here, but we end up getting quite close. The second way that the archive can be challenging is that it's incomplete. In terms of cookies, if you set multiple cookies on a page, this is a legal thing to do, the Wayback Machine will only archive one of them. It will archive the last cookie that you set. This is unfortunate. We miss out on some cookies, which are important to tracking. Entire pages can be missing. So for example, the Wayback Machine says that this Craigslist post, it just doesn't have it archived. This is pretty rare, actually, in the top 500, though, since they're such popular sites. So this isn't a huge deal in our study. Another way that resources can be missing is that you can have images missing. So for example, every single image on this page is missing, even though the HTML is archived in this snapshot. Fortunately, these are less bad than you would think, because we still see the requests for all of these missing resources. Even though we never actually get the image back, we know what URL it was, we know what domain it was on, we know if it was a first-party or third-party request. The other way that we can miss out on things is that sites can opt out of being crawled and being archived. So if you set a robots.txt file, the Wayback Machine will respect that. So what's a robots.txt file? Here's an example of it. This is DoubleClick's robots.txt file. It's just a policy file which makes a polite request to automatic crawlers that they not crawl certain parts of your domain. And the Wayback Machine respects these requests, so the entirety of the advertisements from DoubleClick are not included in the Wayback Machine. And interestingly, something that it does is the Wayback Machine respects these preferences retroactively. So if the Wayback Machine has 15 years of archives of a particular page, and then the current owner sets a robots file that says, please don't crawl me anymore, they will stop showing that 15 years of archives. And so we can have a lot of data sort of disappear because someone decides now that they don't want their domain crawled anymore. And so these various things here that lead to missing data in the archive are going to inevitably lead to some error, and they're going to influence the way that we do our analysis. We sort of have two broad choices. We can do our normal analysis. We can look for cookies sent on third-party requests. This is going to undercount. It'll give us a lower bound on how much tracking we can see. We might also use a heuristic of overcounting. We might say, let's count all third-party requests, regardless of whether they have cookies. This is certainly an overcount, because some of those requests didn't have cookies. And in the validation section of the talk, I'll talk about how this undercounting and this overcounting end up relating to the ground truth data that we have. The last challenge I'll talk about is inconsistency. This is best illustrated with an image. Here's a snapshot of CNN from 2008, and you will notice that it has content from both 2008 and 2012 on the same page. This doesn't represent the web as it ever looked at any point in the past. And the reason is because the Wayback Machine basically made a mistake. It rewrites URLs, and it rewrote them wrong, or it failed to rewrite some URLs. Some of the resources might point to archives with the wrong timestamp, or they might even point to the live web. When these requests point to the live web, in our tool, we block them in the midst of crawling to prevent them from having any effect on our data collection. If we get archived requests that have timestamps that are far away, we handle that in analysis. We look for timestamps that are far away from the timestamp that we're interested in, and we ignore those requests to make sure that we don't get any of these anachronistic, erroneous data tainting what we learn. So next I'll talk about the validation, because we've already removed all of this anachronistic data, but we still have a little conundrum. How are we going to tell that what we have left reflects real trends? We know that the things we're measuring actually were happening in the web at some point in the past, but are they proportional? Are they reflecting trends? Fortunately, we have some ground truth data. Some of our authors published a 2012 paper in NSDI in which they developed a taxonomy of tracking and a method for measuring those trackers, and they measured the prevalence of them. And we've repeated those measurements over the last 5 years. So we have a number of ground truth data points, 2011, 13, 15, and 16. And we can analyze the difference between our ground truth data and our archival data and see if one seems to be reflecting the other. So for the purposes of the talk and for time, I'm only going to give you one result from the validation. There's more in the paper to which I refer you if you're interested. So on this figure, the y-axis is the number of distinct trackers that we see. And on the x-axis, we have time for these 4 data points of ground truth. The black line is our ground truth. It's the number of trackers that we saw on the live web in these 4 years, increasing for 3 years, or increasing for 3 data points and then decreasing for 1. Above, we have that overcounting that I discussed earlier. just considering all third-party requests to be tracking requests, whether or not they have cookies in the archive. And so that's an overcount, as we expect. Below here we have, if we're strict about it in the archive, if we say, what are all the places where we see third-party requests and cookies? And of course, this is an undercount because we could be missing cookies, we could be missing requests. And we see that the relationship between these is actually quite stable. They follow the same trend, and the ratios between them remain pretty close to the same throughout. So this is a pretty good proxy for what the ground truth data is in this respect. And as I said, there's more analyses like this in the paper, but for now I want to get on to the results. So I'll talk about a few pictures, a few lessons that we took away from doing this 20-year longitudinal study. So to remind you, our input data set here is the top 500 most popular sites from each year contemporaneously. We looked at these popular sites because we think that it reflects sort of most of the tracking that most users experience, and because we have ground truth data for those top 500, and so we're able to calibrate. So you're probably going to have this intuition that web tracking has increased over time, and I'm not going to disabuse you of that notion. We agree with your intuition, but we're scientists. I think it's worth backing up our intuitions with data. And one thing that I value about backing up intuitions with data is that I think we can be more precise about what we mean. We probably have this thought in our head that web tracking has increased, but what do we mean? One way of looking at it is to say, how many different players are there in the tracking ecosystem? And what behaviors are they performing? How are they tracking people? And so this figure addresses that. On the y-axis, we have the number of trackers that we see in the data set. On the x-axis, we have time. The gray bars are the total number of trackers, and the colored lines are different types of trackers in our taxonomy. And so the colored lines add up to the height of the gray bar. You can see recently some increases in more complicated tracking types near the end. And so this shows that there are more trackers in the ecosystem, but many third parties knowing a little bit about you is probably not as bad for your privacy as a few third parties knowing a lot about you, right? You can get a really rich picture of someone. It seems like you have a lot more data to work with. And so we might also want to ask, what is the coverage of the most popular trackers that are on the most sites? And this figure addresses that. On this, we have time on the x-axis. Each individual line is a single third party that we saw in the archive. And on the y-axis, we have the fraction of the top 500 sites on which that third party appears. And so the lesson here is fairly natural, that we've grown dramatically, even in the last few years, in terms of the total number of sites, and therefore the size of the browsing profile that various of the top trackers on the internet can see you on. So the power of individual trackers has grown over time. Individual companies know more about you. They can derive more about you. Another lesson that I get from this figure is if you look at this outlier up here, this is Google Analytics towering above the rest. And what's interesting about Google Analytics is that their main purpose is not to track you across sites. Their main purpose is to track you within sites to provide analytics services. But the fact that they're on many sites gives them a lot of power, right? Their decision whether or not to track cross-site, to track you on the various sites that they're on, or just to track you on the individual site, is a big inflection point for privacy. Their choices gain a lot of power. So the individual choices of Google Analytics matter a lot. If we know what their choices are, that'll change the privacy perspective. And that if we want to know about privacy, then transparency is really important. Because if we can't tell whether or not they're tracking cross-site, then we have a much less complete picture of what our privacy looks like on the web. I have one last result for you, which is we talked amongst ourselves about the worst days of the web. What do the worst days of the web look like? They look like this. How do pop-ups relate to tracking? The answer is that pop-ups are actually one of the types of trackers that we discussed in our taxonomy because they enable stronger tracking. They enable a tracker to defeat certain defenses. By popping yourself up in a pop-up, you become a first party inside of that pop-up, and now you can set cookies, even when third-party cookie blocking is enabled. So we looked at third-party pop-ups in the archive. We see this spike rising rapidly towards 2004, and then after 2004, rapid fall off, and they sort of disappear. What happened in 2004? Well, Internet Explorer started blocking pop-ups by default, and other browsers around the same time as well. What I find interesting about this is that this wasn't a tracking-related decision, right? The engineers at Microsoft probably were not thinking about tracking, they were thinking about user experience. They were thinking, people hate pop-ups. We want to make this better, right? And so the interesting thing here is that the choices of entities like browser manufacturers might have much more influence on what kind of techniques are effective and are used by trackers than tracking defenses or anything like that. The ecosystem of technologies in which an attack and defense sort of exchange happens can matter just as much as the things that are explicitly thinking about that exchange. So I told you earlier on in the talk that I wanted to study, I thought that we should study web tracking over time so that we could see the trajectories and how it fits into the context of the web. And we did just that. In this work, we studied web tracking over 20 years from 1996 to 2016. If in 5 or 10 or 20 years in the future, we realize that we should have looked at something else, we can also do that with the methods that, that I described in this talk. And so that's my hope for this work, is that we'll be able to go forward and it will enable us and other researchers to study a whole variety of web measurement topics longitudinally and get better insights about the way the web has changed. Thank you so much for listening, and I would be glad to take questions.
Say your name and affiliation.
Sure. Paul Van Oorschot, Carleton University. Great talk, really useful tool. I agree that others will find it useful. Is there actually enough information in the archive to know that tracking was occurring, or that these parties had the ability to track if they chose to?
So the question was, I believe, is there enough information in the archive to know whether they were actually tracking you or if they just had the ability to? Yeah. What we measure is the ability to track. And that's true for even the live web measurements. We have no idea what they're doing on the other side. If you want to do that, you need to get some work where you see the effects of tracking. You look at the targeted advertisement and see.
So what's your intuition between the gap between the ability to track and actual tracking? Just your guess.
My guess? It's probably not an insignificant gap, because if you look at the data manually, you'll see a number of trackers who you're not sure whether, I've never heard of this entity, but it's really hard to tell. So.
Thanks for a really awesome talk. Sid Stam from Rose-Hulman Institute of Technology. So I'm curious about when you were getting data out of the web archive, because landing pages and deeper pages in a website are going to have different composition of third parties. Did you just check the landing pages of the top 500, or did you go deeper?
Yeah, we just checked the landing pages. That's definitely a limitation of this work. One of the limitations that comes from is that, unlike browsing the live web, parallelism doesn't help you with the Wayback Machine, because you're hitting one set of servers and they're pretty slow. And so crawling a large number of pages within each site takes a very, very, very long time. But that's the kind of thing that in future work I would like to explore, is sort of how can we get that kind of deeper into web pages data out.
Alex for DC Google. Earlier on, you talked about cookie-based tracking. Is this research all about cookie-based tracking, or did you look into other things like JavaScript bugs and cache bugs and stuff like that?
This is all about stateful cookie-based tracking. We did a little bit of analysis we looked at, for example, the use of the JavaScript local storage API, because that's another way in which you can store state in the browser. But that's all that we looked at in this study. I definitely have my eyes on future work that looks at all manner of other things. So if you have ideas for what you would like to see studied longitudinally, let me know. I'd be glad to do that.
Thanks.
Rabimbo, Rice University. Since you have all this data, did you try to look at how they track at past and how they evolved tracking? Did you look into how the measurement changed?
I'm not sure. I missed the middle of that question. At the end, you said how measurement changed?
So how they used to track in 2004 or how they used to track now, did you see any, did you try to see that, if there was a change or what change?
Yeah, so the different colored lines in the figure with the gray bars are different types of trackers. So they have different behaviors. They are referring to each other in different ways. They're using different techniques to track. So you can see the changes in those colored lines. Yeah.
Thank you.
And one more quick question.
Sure.
The 20-year graphs that you showed, were those based on the upper bound, the lower bound, or somewhere in between?
Those are based on the lower bound. Those are based on being strict about it.
Thanks.
Yeah. Sorry, actually, the first one is based on that. The second one with the third parties is actually based on all third-party requests. And the reason is because with those really popular ones, we can afford to do a little bit of manual analysis, right? DoubleClick appears on that figure. DoubleClick appears on this figure, for example. Oops, back one more. The red line is DoubleClick.
Right.
Which I told you, DoubleClick doesn't have any cookies. It only has third-party requests in the archive because they block all, they opt out. But the reason we can do this is because we know that DoubleClick is a tracker. We are able to manually investigate that fact and include it on this figure. And the manual investigation is feasible because we're only having to do it for a small number of trackers because the big ones are the important ones.
Thanks a lot. Awesome research.
Thank you.
Hi, Trevor Pottinger from Facebook. So there's actually on that same slide.
Sure.
So a lot of these domains are actually all owned by Google. Did you guys try doing any analysis of trying to deduplicate based off of which company actually owns the domains or the trackers that you observed?
No, we didn't. That's something certainly that I'm definitely interested in. But for the purposes of this, we didn't.
Cool. Thank you.
Thank you.
All right, and with that, let's thank our speaker one more time.